All right, so we ended the last video with this summary of infinite limits of rational functions. So we had these three rules that if the numerator power is less than the denominator's power, or the degree, then it's zero, meaning the denominator has a bigger power, then it's always going to be zero. If the numerator has the bigger power, then it's always going to be either positive infinity or negative infinity. We're going to have to just do a little evaluation to check. And if the degrees are the same, meaning the highest powers are the same on the numerator and denominator, then the answer is going to be the ratio of the leading coefficients. So these are, again, our limit rules for rational functions. We also said that for any polynomial, which we use this notation here, of degree n, we only have to find the limit of the highest degree term, then we can ignore the rest, and that will tell us our limit of an infinite limit at infinity. All right, so let's go ahead and jump into some practice problems here. So we'll start with just some basic polynomials, and we're going to find the limit as it goes to both infinity and negative infinity. So the limit as x goes to positive infinity of f of x. We want to find the highest degree term. That is going to be this term here. Make sure you circle the sign that goes with it as well, because that's going to be important. We can ignore the rest because, as we said, the biggest degree term is going to dominate whatever any of the other terms are doing in this function. This is a 1/3 here, if you remember how to turn that into a rational exponent. So the x squared is the biggest term. So essentially what you're thinking is direct substitution. If I were to do -2 times infinity squared, what would this equal? Well, if you square infinity, right, that's just going to be infinity still, right? Square a huge number. Think of this as a really big number. Square a really big number comes to be even bigger, but then you have to multiply it by -2. So as you plug in bigger and bigger numbers, they're going to get big and big, but then you multiply them by -2. So ultimately, this is going to take you to negative infinity. And then if you plug in the limit as x goes to negative infinity of f of x, again, just look at the biggest term. This is really -2 times negative infinity squared. Now, again, think of negative infinity as a really big negative number, so like -1,000 or whatever. Well, you square it, so it's going to become positive. So all these negatives that are really big, you're going to be squaring them, they become positive. You then have a positive number, times a -2, which is going to be a negative. So this is actually going to be negative infinity as well. So just think logically through this. If you also plug this into your calculator, you could do so. You could plug the whole function in if you want to, or you could even just plug in the highest term. If you just plug that in, that will actually work too. Just to confirm, you do need to be able to do these without a calculator, but you can just plug it in to confirm. You should actually know that this one, without even looking at a calculator, looks something like that, right? Both, as we go to negative infinity, the function goes down to negative infinity. As we go to positive infinity, the function also goes down to negative infinity. This will be familiar from last year when we talked about end behavior. This is exactly the same thing as end behavior. In fact, when you see these limits as x goes to positive and limits as x goes to negative, think of this as just this synonymous with end behavior. And you could even just look at the term, look at the sign and the power, and you can draw your conclusions based off of that. All right, so next we've got a rational function. All we want to do in these is identify the biggest powers in the top and the bottom. So we've got the top one there, here, and just kind of view this as -4x squared over 9x squared, like that. Right. So the limit as x goes to positive infinity of this function, compare the biggest powers there. They're the same, so our rule is if they're the same, we take the ratio of the leading coefficients. Well, the leading coefficients here are -4 and 9. So this is just going to be -4 over 9. Same with the negative limit as it goes to negative infinity. It's going to be the exact same thing, -4/9. if you don't believe me, we'll do a little test case here. Plug that whole function in your calculator, because you probably don't know what that one looks like. This is what our function looks like here. Goes up like that. And what's happening here is there's actually a horizontal asymptote right there. So as we go to negative infinity, the function is getting closer and closer to this invisible line here, which is at -4/9. That's what this invisible line is right here. And as we go to positive infinity, the same thing, our function is getting infinitely closer to this line -4/9. Again, that's the same thing as the end behavior. Limits as the value goes to positive and negative infinity are exactly the same as finding the end behavior of a function. All right, let's look at the next one. Find the biggest power here and here. Limit as f of x as x goes to positive infinity. Make sure you are still writing these out. Don't just skip writing the limit part. That is important. So we've got the bigger power on the top. When we have the bigger power on the top, if you look back at our rules, then we actually have to do some work here, because if the numerator is greater than the denominator, which we have, it's either going to be plus or minus infinity, but we have to do some plugging in and checking. And I'll show you what I mean by that. Just take these two bigger terms here, 3x to the 7th over -10x squared. Again, make sure you keep the signs and plug infinity into these. So we plug in infinity here, plug in infinity here. And really all we care about is what is the sign going to be on each of these. So the top one is going to grow faster, right? Obviously, but it is going to be a positive, right? The bottom's not going to grow as fast, but it's always going to be a negative because we're going to be multiplying it by -10. So we got the top is growing faster, the bottom's not growing as fast, but we have a positive number over a negative, which means overall this function will be negative, right? A positive over a negative would be a negative. So this function actually goes to negative infinity. These will probably be the most challenging ones to figure out, but you just have to use some logic and figure out what the signs are going to be on the top and the bottom. So the next one is the limit as it goes to negative infinity. We use the same strategy here. Think of this as 3 times negative infinity to the 7th over -10 times negative infinity squared. Well, on the top, we're going to end up with a negative because a negative to the 7th power would stay negative. So a negative on top. The bottom, we're squaring that negative infinity to make it positive, but then we're multiplying it by -10. So we have a positive times a negative, which is a negative. And then overall, we have a negative over a negative, which is a positive. So this is positive infinity. For the next one, just identify the biggest terms first. Highest degree on both of those is a 4. So think in your head what's going to happen. This is going to be the ratio of the leading coefficients. So we've got the limit as x goes to positive infinity of f of x. Ratio of those leading coefficients is 20 over 5, which is just 4. And it will be the same for the negative one as well. I still want you to write it out. 20 over 5, which equals 4 in both cases. Next one, identify your biggest powers. 3rd on top, 5th on the bottom. So the denominator is bigger. If you think back to the rules on this one, whenever the denominator has the bigger power, this function is going to go to 0 as you go in either direction because the denominator gets bigger than the numerator, which takes it to 0. So our limit as x goes to positive infinity of f of x is going to be 0. And the limit as x goes to negative infinity of f of x is also 0. So again, think about the implications of this. This is saying as we approach infinity in either direction, it is going to approach 0. If we plug this into our calculator, just to see how this all connects, what we're doing here, Again, very similar to end behavior. We'll just call it something different. This is what our function looks like here. On your graph, it actually kind of looks like it stops there, but what's happening is it's getting infinitely close to 0 there. And then you kind of got this little squirrely thing here. And then it's actually getting infinitely close to 0 there as well. Your graphing calculators aren't the best for seeing this because they don't have enough pixels, but that's what's happening. As we go to positive infinity, we're getting closer, infinitely close to 0. And as we move to negative infinity, we're getting infinitely close to 0 as well. All right, let's get a couple more. Here, identify the biggest powers. We've got a 6 on top and a 6 on the bottom. That means it's going to be the ratio of the leading coefficients. So we got limit as x goes to infinity. Well, this is an invisible 1, so it's just 1 over 7. Will be the same for both of them. Negative infinity as well would just be 1/7. So those are easy ones. All right, now this one's going to get a little bit more challenging. Can't end without doing any hard ones. So if you look at the biggest powers, first of all, you might think, well, we've got an x squared and then an x, so top's bigger. However, you might have noticed we have this square root here. That changes things a bit because the square root, think about if we were to sort of just pull out the biggest terms in the same way that we have. So if we were to just look at the top and the bottom, we can't just ignore this square root. So what I want you to do is think of this as the square root of 9x squared over negative 2x when we look at these biggest terms. Because again, we can't just ignore that square root. So think of it in this way. If we were to simplify this, we're kind of ignoring some rules, ignoring obviously the fact that this is here, right? Ignoring the fact that 7 plus this there. But again, we're just looking for the biggest terms. So that's why we're doing this. If we were to simplify this, reduce this, this would actually turn into 3x, right? Because the square root of x squared is just x. So it would actually turn into 3x over negative 2x. And that's the better way of looking at this because that squared power is going to get sort of reduced by that square root because really this 9x squared, square root of that is equivalent to saying 9x squared to the 1/2 power. And then when you do it to a power, you multiply them. So it's 9x squared times 1/2, which is 9x. Sorry, that should be the square root of that too. So it'd be 3x to the first power. Gonna remember those exponent rules from back in the day. All right, so this is actually what we want to look at in terms of our biggest powers. So now you can actually see the powers are the same because they're both the first power. So the limits then are just going to be the ratio of the leading coefficients. So this would just be negative 3/2 from both directions. Just make sure when you do this, it's very easy to forget to take the square root of that number in front as well. But if you just sort of break it apart by this, take out the biggest powers, then you're good to go. All right, and let's see one other one like that. So maybe two more. Typically when you see these, it's going to end up being that they're the same power. And that will be the case again here. We pull out the biggest powers here and here. Again, we cannot ignore that square root. We get x over the square root of 2x squared. So in simplifying that denominator again, we have x over radical 2x. We don't know the square root of 2. It's a decimal, right? So we want to just leave it as the square root of 2. But that x squared, square root of that does come out as just x. So we have the same powers again, which means it's going to be the ratio of the leading coefficients. So the limit as x goes to infinity of f of x, it's going to be 1 over radical 2. Now, we don't want to leave it as 1 over radical 2. You will not see that as an answer on the AP test because that is not the right way to leave an answer. We do need to rationalize this by multiplying by radical 2 over radical 2. So we get radical 2 over 2 is our final answer, which would be the same for the limit as x goes to negative infinity, radical 2 over 2. Okay, one more here. Got another square root one. Identifying the biggest powers. These two. Negative 4x squared. Cannot ignore that square root. So we get square root of 7x to the fourth. And as you can imagine, it's going to end up being the same powers. I like to throw these in at you. Hopefully someone forgets what they're trying to do is trick you into forgetting to take that square root. When we take the square root, we end up with square root of 7x squared, because this x to the fourth to the 1/2 multiply 4 times half gives you 2. All right, so these are our leading coefficients. Limit as x goes to infinity, negative 4 over radical 7. Again, that's not going to be on the AP test because that's not the right way to write an answer. So multiply by radical 7 over radical 7. Negative 4 radical 7 over 7 is the answer for both the positive and the negative. All right. All right, last one. I got a question here. Just a quick check. All right, identify the biggest powers. These two. Let's go ahead and circle them. The bigger power is on the top, which means it's going to be either positive or negative infinity. Now, we're only asked to find the limit as x goes to negative infinity on this one. So sort of make the substitution. 5 times negative infinity cubed over negative 3 times negative infinity squared. And just think about what the signs are going to be. On the top, we're going to cube a really big negative number and then multiplying it by 5. So that's going to be a really big negative number. On the bottom, we're going to square that negative infinity. So it's going to become positive. But then we're going to multiply it by a negative 3, which means overall it's going to be negative. So a negative over negative is a positive. And we know that it's either going to be positive infinity or negative infinity. So since it's positive, it's got to be positive infinity. All right, reach out to me if you have any more questions over that. And good luck, guys.